Okay, this is part 2 of Unit 60, looking at the normal distribution. And we're looking at question number 20. We just went over the 68, 90, 95, 99.7 rule. And now we want to look at this data where we have a resting heart rate for a sample of individuals are normally distributed with a mean of 70 and a standard deviation of 15. So I've drawn a picture to the right here. It's not the best bell curve, but the center is 70 because that's the mean, and the standard deviation is 15. So if we go up one standard deviation in the positive, that's 85. If we go up 2, that's 100. And if we go up 3, that's 115. Now if we go below, we're going to subtract off 15. So that's going to be 55, 40, and then we'll drop all the way down here to 25. So that's, again, we're 1 standard deviation, 2 standard deviations, and 3 standard deviations above. And then we're 1 standard deviation below, 2 standard deviations below, and 3 standard deviations below. Now we're going to use this information in order to try and determine the answers to these questions. I'm going to try and draw some straight lines here, although I may miss a little bit. But so here's my 1 standard deviation. So that 68% is contained between 85 and 55. And then 2 standard deviations out, that's to 100 and to 40. And that's 95% of the data is between 40 and 100. And then at 115, 25 between those two. Let's fix that one. You're 99.7% of your data. So in this example, we want to figure out what percentage, and I'm going to try and do my best not to erase too much things here. What's the percentage of heart rates that are greater than 85? So we want to figure out essentially how many are in this shaded region right here, above 85. So as we think about this, okay, this will be part A here. When we're looking at it, we know that there's 68% in this region right here, because that's between 1 standard deviation above and below. So then that means that if there's 68% in the middle, there has got to be 32%, the remaining 32% has to be distributed between those two sides outside of the 68. So essentially below the 68 there's going to be 16%, and above the 68 percent line, so above 85, there's going to be 16%. So if we take 16 plus 68 plus 16, that'll give us our 100. And notice what we've done though, right there, is we found out that if we are above 85, then 16% of the data has to be above 85. Because again, outside of that 68, 32% has to exist, so half is below, half is above. So in this case, if we are greater than 85, then there would be 16%. Hopefully all that makes sense. So now I'm going to try and erase without erasing my blue stuff here, and look at part B. So part B says less than 40. So anything less than 40, so here's 40, and we're everything below that, as far down as you can go. Well, 0, because 0 heart rate, people don't go in the negative heart rate. 0 heart rate is you're not living, but that's as far down as it's going to go. So to be less than 40, okay, well let's think about this for just a minute. 40 is 2 standard deviations below. So between 40 and 100, that's 95% of your data. So we know that below 40 has to be less than 5%, or yeah, less than 5%. But 95% is between 40 and 100. So then the remaining, we take 5% and divide by 2, and that's 2.5%. So 2.5% is going to be above 100, and 2.5% is going to be below 40. Because notice now if we add 2.5 plus 95 plus 2.5, we get 100. So below 40 has got to be 2.5%. And again, all of this is using the approximations of the empirical rule based off of how many standard deviations we are above and below the mean. Oops. Okay, next one, C. We want to know less than 85%. Now, we already found greater than 85% to be 16%. So if we just look at what's called the complement of that, if we know that above 85, this is 16, then we can take 100% minus that 16% to get how much is below there. So we just take 100% and minus that 16%, and we'll be at 84%. So that's how much is going to be below 85, or less than 85. Because once we know greater than 85, then we just take 100% and minus that number, and that'll give us the portion below. Okay, looking now at part D, less than 100. So if we look at less than 100, okay, that's going to be all of this stuff right here. So we want to know all of that data. So remember, so 100 is 2 standard deviations above and below. So remember, from between 100 and 40 is 95%. So then on those two tails, like we talked about in the last one, 2.5% is in this tail and 2.5% is in this tail right here. So if we are less than 100, then we would just take 95 plus 2.5 to get 97.5%. And that would be how much is less than 100. So let's delete these out. Hopefully this is making sense as we try and go over several examples. So E, greater than 70. Now 70 is the mean, so it's right in the middle. So anything greater than the mean is going to be 50%. 50% above the mean, 50% below the mean. Okay, F, less than 55. So that's going to be all of this right here. And so 55 is 1 standard deviation away. So that area here is 68%. So again, that leaves 32% remaining in each tail. So that means there's 16% here, and there's also 16% below the 55. So that's going to be 16% for this value, or this portion right here. Okay, next we are looking at G, greater than 40. So remember in part B we did less than 40. So less than 40 on part B was 2.5%. So we would just need to take 100 minus 2.5 and get 97.5% is going to be, in this case, greater than 40, which is all of this area under the curve here. And then lastly, the one that is most fun is H. I'm going to do this in a different color here. So H says between 55 and 100. So what we're looking for is this area right here. And the easiest way to do this is to think of it as, let's take the percent. So let's say the percent less than 100. So the percent less than 100 is going to be all of this right here. So let's take that, and then we need to subtract off less than 55, because if we subtract that off, then we'll be left with between 55 and 100. So we're going to take percent less than 100 minus the percent less than 55, and less than 100 was D, so that was 97.5, and less than 55 was F, which is 16. So when we subtract those two, we get 81.5%. Okay, and that right there is going to be the number or the percentage between 55 and 100. So that's how we would use the empirical rule to find data values or percentages given the standard deviation, the mean, and then some questions there that we were asked. So hopefully with all those examples you get an idea as to how that will work. Okay, the next thing we're going to talk about is what are called standard scores. And these scores are really helpful. They're also known as the z-score, because again, remember that the 68, 95, 99.7 applies to values that are exactly 1, 2, and 3 standard deviations above the mean. For other cases, we can generalize this rule if we know precisely how many standard deviations there are away, a particular point is away from the mean. So the number of standard deviations the data value lies above or below the mean is called the standard score, or a z-score, often just abbreviated by the letter z. So if you see a standard z-score of z equals 0, that means that is the mean. It's 0 standard deviations above or below the mean. If you want something that is 1.5 standard deviations above the mean, that'll be a z-score of 1.5. And if you're 2.4 standard deviations below the mean, that's going to be a z-score of negative 2.4. So what these standard scores are going to do is we're going to be able to take distributions that have any mean and any standard deviation, and we're going to be able to take them down to a z-score that will tell us exactly how many standard deviations it is away from the mean. And here's how you find it. You take the data value, you minus the mean, and then you divide by the standard deviation. That will give you the z-score, or the number of standard deviations that particular point is above or below the mean. So in this example here, number 26, we have a mean of 67, standard deviation of 8, and we want to know what the standard score is for 71. So this would be z equals, you take that data value minus the mean, 67, over 4, which is the standard deviation. Excuse me, 8. Got ahead of myself. 71 minus 67 is 4. So this is 4 over 8, or 1/2, 0.5. So this tells us that the data point 71 is 0.5 standard deviations above the mean. Now you may be thinking, well, if the standard deviation is 8 and the 71 is 4 units away from 67, we can easily decipher that that's just half of the standard deviation. But when you get numbers that are really ugly, it's much easier just to convert these over, and then we're going to be finding in the next video percentiles, and finding percentiles and having these z-standard scores is going to be very helpful when we look at this table as far as where we're going to start there. So that's just a look at standard scores. We'll continue in a part 3.